Okay, announcement-y stuff. Today we're going to go over percentages for the math science topic. We've done it a little bit last week. We've done it a very tiny bit on Monday, but life has been happening. Everyone's brains are full of other things. And for some of the things we've done since then have probably muddled it more. So we're just going to sort of go over percents again. And that will be a good place. A second announcement, the third example problem with the goes with chains was terrible. People were almost understanding sometimes for the first two examples, and then I did the third terrible example, which I really should have rehearsed at home before trying it before other people. And all of your eyes went dead because it was just, it wrecked everything. So I put in better examples there. If you click here, then there's lots of other example problems. And if you're interested in that, you can try them. I'm not going to rush myself to spend more class time on that because it's really just a transition topic to unit analysis, which we will get to soon and which works better. But if that was something that you were feeling like you were getting close to doing, then look there and maybe ask me Friday for something in class if that would help you. Unit analysis comes at the end of this second section of the class, and it works very well, but it doesn't teach you an intuition of why it works. So what I was trying to do, somewhat unsuccessfully, was build up your intuition on why this might be something to do before we do the process that's efficient, but kind of too efficient. You can't see what's happening behind the scenes. And it almost worked not quite. So if this term just didn't work because I messed up, next term it'll work better, that might be enough. But if this is something that's almost helping your brain but not quite, then play it on. But for now, let's just work on that. Also, achievements. It's getting late enough in the term that some people like having paper copies of your achievement pages. So if that's you, then let me just get a quick count. Who wants a paper copy? 1, 2, 3, 4, 5, 6, 7, like 8. I'll do 10. So I'll print them out nice and colorful at home where I have a color printer because that's nice. And each day I'll bring my colorful stars with lots of different kinds, and you can literally put stars on and whatever. So yeah, some people really like that, and you can do that too. A couple of things I just wanted to highlight announcement-wise was that I messed up when I was writing the syllabus because I was doing a whole lot of Math 20 website redesign at the end of December. And the thing that interested me least was the syllabus. I forgot that to say that the earn a D section, do a syllabus quiz, and the core learning outcome assignment, I forgot to say that was for anything other than a D. So I guess officially, if you're earning a C or more, you can skip those. But they are good things to do. So I would still do them and pay the little stars. If you're not sure what they are, it's because you've never clicked on them. So go ahead and click on them, and it's pretty obvious what's happening, right? But okay, for the people that are earning good letter grades, which is everybody, then you're starting to see things. So 8 homework stars. We haven't really done 8 homeworks yet. Some people are rushing ahead and have 8 for 32. Whoops, actually, one of them is 5. So up here, there's 5. And some people have that one checked off. Let me grab somebody who has a bunch. Drake has a bunch. Right, so some people have the 5. I'm not putting the check marks for that you've done 5 or that you've done 8 unless you tell me about it. At the end of the term, when I'm giving you a letter grade, I will double check that no one is getting checked on things. But I want to have a little mini celebration with you where you say, I've done my 8th one, give me my star, whether it's in class or in email. And I say, you have, hooray, right? So notice when you have gotten that threshold met, and then you can do that. With the pop quizzes, people have done 1 or 2 pop quizzes now, so you're getting stars there.
Do we need to tell you?
What?
Do we need to tell you when we pass our pop quiz?
The quizzes I'm just waiting.
Okay, so we don't have to.
But if I forget one, then yeah, you don't want me. And then the turning in the nice notes, some people have done that, some people haven't. The tricky thing for the notes, remember, is going to how to do notes. You need to merge these 4 sources of information. What I give you, what the textbook says that's helpful for you in ways that class wasn't, what you wrote during class, and then things in your head. So if you show me some notes that look very nice from class, my immediate question will be, is there anything that's not from class? It's an example problem from the textbook that helps you, but I didn't do it. Some way of explaining things that the book had that you like better than what we did. And if you don't have any of that, then I will say your notes look great, but you haven't done what's assigned yet. Because the whole point is that when it's time to cram for a midterm or a final, you don't want to have to take out your notebook and your textbook and try and be piecing sources of information together. You want it to be efficient, where, oh yes, I was having trouble with percent change, but all of what I wanted about percent change to help me is right here on these pieces of paper, and I can just look at them and study. Does that make sense? So you don't have to do that for every topic, because you don't have time to do that for every topic. But you need to prove to me that just a couple times you can do that, so that when you move on to your next math class, I will know that, yes, if you really needed to, and to earn an A, you only have to do that 3 times. So that's not too much work. You can compile things from different sources of information 3 times during 10 weeks. Okay? And then I'll know that whatever your nemesis is in Math 60 or whatever other class you go to, if you needed to, you could get nice, robust notes to help you study. Yes?
What if we do work for like B or an A, we test it well?
You need to test well, but I very seldom have anyone do enough work, get 11 homeworks done and not get the percentage they need. So also, as I mentioned, not only can you take an infinite number of practice finals just by loading this page lots of times, and every time you load it, the numbers and questions change, but you can even take one that counts early at the MRC, have them proctor you. So if you are nervous about getting this 85% to get an A, then don't make the final exam during finals week be the first time that you're going for it. Okay? During week 9 or week 10, have me put one for you in the MRC, and then you can see, yay, I got 80, or I got 85, or whatever. Yeah.
You can take it as many times to get a better grade.
Maybe like 2 or 3. It's not fair to the MRC staff if you're there every day.
Well, I don't have that much time. I'm saying I could go in there like
Yeah, if
every
you take it week 9 and you want to do better than that, then try it again. It's,
I was worried.
I just know that these images, when you click on them, they link to the references that you're.
some of them do,
It's
yes.
pretty funny.
So,
I just noticed that.
yeah, some of them are links for things. Play around it. Okay, so
I'm not that good at this too.
any other just questions about grading or the pace of what we're doing or other class-wide issues before we start doing it?
So if we want to aid, just focus on the
Right. And the achievements are designed that they build off each other, right? So to get a B, come here, then you need 10 homeworks and 2 notes and 2 quizzes and a pretty good score on the test. But by the time you've done that, you might as well turn in 1 more homework and 1 more notes and 1 more quiz and go for the A, right? So the idea is that it's going to encourage you.
How many quizzes will we have?
We'll do 1 each Friday, right? So we'll have a bunch more.
So you just choose not to do it, you just-
If you have to be absent Friday, that's not the end of the world. Oh, by the way, I probably shouldn't tell you, whoops, but I've already put up what we're doing Friday. So if you want to look ahead and be extra prepared, you can. Yeah, you might want to do it by yourself or you might want it with a group. So spy on what's happening. Let's see. It's different than before. It's not quite as projecty as before. But something has, well, I can talk about it. I can talk about it. So what we're going to do is sort word problems. I'm going to give you a bunch of word problems. Some of them you use addition, some use subtraction, some use multiplication, and some use division. And I want to see how accurately you can just tell me which one is the right tool to solve it. You don't have to actually solve it.
Oh,
And-
just by reading it?
Yeah, read the problem and say, is this a multiplication thing or an addition thing or what's happening? because, has anyone heard of the deficit model education? No, you don't hang out at teacher meetings. So the deficit model
Obviously.
is that there's more than one, but it generally means that students show up sort of weighted down by baggage. And it might be something that's about you, it might be something about where you grew up, it might be something about teachers you had, but students come with some sort of deficit holding them back, slowing them down. And part of the job of teachers is to get rid of that, whatever the obstacle is, so that they run around at a good speed. Does that make sense? In math, then let's actually do this. Raise your hand if you have had what you would call a great math teacher in high school or college before now. So not a lot, right? We have maybe 4 or 5 people in the room. So that's normal. It tends to be true that if you have a good or great math teacher, then you show up at LCCs at either feeling good about Math 20 or you skip Math 20 entirely. The deficit that the math department deals with is that if you've never had a good math teacher, then we need to be your first good math teacher. Does that make sense? It's not your fault. It's not like you get to pick your high school math teachers, but that's the, kind of the thing we're dealing with, that there's lots of things that you should have been taught, and if through no fault of your own you weren't, then we need to figure that out and sort of fill up the holes. So one of the examples of that is just knowing how to sort your word problems. Right? We know you can do the arithmetic, but if you don't know what arithmetic to do, then that's a problem. And have people taught you that or not? So I'm going to check that on Friday. It is more a test of your teachers from before than you, if that makes sense. Well, that can be true. So yeah, Friday, I'm not really testing you. I just need to sort of know what's in the room so I know how much I need to do. That makes sense? So that's one reason you only need 3 quizzes out of like, what do we do? 7 different quizzes, 7 Fridays we have things. So the deficit model tends to be like a bad word in education because there are lots of people who are bigoted and tend to make up deficits that are bigoted kinds of things. Women can't do this. People from different cultures can't do this. So it can be misused. And so people don't tend to talk about it as much as they used to like 30 years ago. But yeah, not everyone has the same educational background. It's usually not their fault. So there we go. Okay, inspiring music. Okay, any questions in the fractions section before we get back to math and percentages?
We asked for more questions.
Can you ask for fractions? You want? Or you want-
Percentages.
Now let's talk about percentages more and then do the homework for it. So lecture then homework. Okay, percentages then. So we're going to talk about percentages more, of course, when we get to the third topic. So there'll be percentages here, but we're building up to things with what we're doing today. So in particular, we're doing problems that start a number. Things like, what is 40% of 200? What is this percent of that amount? And when we talked about them before, then we noticed that the word of usually means multiply. It's hard to think of a case when it doesn't. So if somebody eats 5/8 of a pizza, example 50, and then her daughter eats half of what's left, then how much did the daughter eat? So when you're doing of in that case, of is multiply. And of means multiply with percentages too. So when I say what is 40% of 200, I'm just multiplying 40% of 200. If you weren't here when I've used the word algorithm, algorithm is just the fancy word for a step-by-step process, like how to bake a cake or how to change the setting on your computer or whatever. So the process for doing percent of is we have to multiply the percent of the number. The only way that's different than other things is that we have to rip off the percent first because we can't put it into our calculator well unless it's a decimal. Remember, the percent key on your calculator is unreliable. So if I want it, oops, I haven't started Starboard yet. Come here, pen. Okay, so if I wanted to do 40% of 200, I'd have to take the 40%, do my riplop. I'm going left out of percent, so it's going to turn into 0.4. And then I would get 8.
Oh, wait.
So not bad. Two things going. Out means multiply. And hey, wait a minute, I can't actually multiply this until I make a decimal point. Is your calculator having issues?
I mean, it's up right there.
I got 80.
That's what I got too.
You got 80. My mental math is broken because I'm thinking, but 4% of 2. Oh, because it should be. Yes, it should be 80.
Okay, that's why I was looking at.
Yeah. Okay. Now that's because I'm funny. You can look at me.
I thought I wasn't gonna be right.
I'm thinking 4% instead of 40%. I can't read. Okay.
I was like, I'm doing this all wrong.
Okay. The only other complication is labels. So if you had what's 60% of 200, then so that's going to be 120. No label there. If we have a label, it just sticks around. So that's what, 20. Now my label was hours, so I should put hours at the end. So far, so good.
And these are calculator. on the test.
Yep, these are calculator ones on the test. Then the final bit of slight trickiness is what if the other label is a percent? Then that's okay. You just treat the second one like a label, just like we did with hours 30 seconds ago.
So it's
So 10% times 50. Oops, why do I have 2 equals? And then the label we're putting on the end, in this case, is the percent.
What's this say?
So don't rip up twice. The second one, we're just treating like a label. Yeah.
Okay. Does it say the left there?
And that's as hard as they get. Okay?
Yeah.
You're multiplying, you're using a calculator, don't stress
It's all-
it. Question?
So,
What would be division problem when it comes to percents?
Oh, good segue. I will pay you up. So this was the multiplying version. We're finding a certain percent of a number that's provided to us. Division would be the opposite. I'll skip all the tipping and stuff. Okay. We'll do many cases of division once we get to the third section, the justice section. But in mad science, the only division we're worrying about is percent change. And partly that's because it's the most common thing you do in real life, so let's start there. Partly it's because a lot of people come to Math 20 having done percent change in real life and want affirmation that yes, my simple way works, this is good, before I teach you the general way, which is more complicated because it's more general. So if you want to find the percentage and there is a change, like a price started at 75 cents, it went down 15 cents, so it's now 60. What was the percent of the change? Then that's where we divide. Instead of being given the percent, now we're looking for the percent. So the opposite thing is happening. So we divide instead of multiply. These examples I've done like twice in class, so let's just get some random ones instead. Random problem.
Do it 7 times.
Yeah. Okay.
Remember last.
So a dieter goes from 161 pounds to 154 pounds. What is the percent of the change? Okay, now when we're doing percent change, the formula is change divided by original. And this formula has two purposes. One, it's something to memorize, plug things into the formula. But two, the names are there on screen. We have to look for the change, and we have to not get confused about which price was the original, which sometimes is obvious and sometimes it's not. So nothing in the formula is the new price. So if you know the new price, either it's a red herring and you ignore it, or it's something you need to find either the change or the original. Does that make sense? So no new price in the formula.
So just kind of sit down.
So,
So what was that weight again?
so I have my percent change formula. In this case, I have an original weight. I have a new weight, which we do, but we do, well, it's not that we do nothing with it. We don't plug it in the formula.
Yeah.
But what we don't have is the change.
So the difference is.
The difference is 7. So we're using the 154 to find the 7. But once we've done that, we're done with the 154. So that's my vote.
There we go.
Okay, so to find the change, 161 minus 154 equals 7 for the change. Come on, A. Go. And then the original is 161. So it's about 4%. All around. Oops. Okay, now 0.04 isn't what the problem asked for. It asked for a percent, not a decimal. So what am I going to do?
Right.
Yeah. So this is doubly opposite of what we just did. On the other slide, we did our rip-wop first, and then we multiplied. So the opposite now is that we start by dividing, and we do our rip-wop last. Right? Everything backwards. Ready for another one?
Yep.
Okay, let's have somebody make one up. Get this blank thing, move it down.
We get a star.
If you come up and do it on the board, you get a star. You want to do your own on the board?
And I'm not that great yet.
Not that yet. Okay, maybe later. Okay, so percent change. We have our formula. Okay, let's make something up. What's our situation where something is changing? Can go up, can go down, sale, investment.
Amount of fluid in a container,
Okay, fluid in a container.
6 gallons or something.
Fluid amount. Okay, it starts at 6 and then becomes 4. Okay, so we have 6 gallons, goes down to 4 gallons. Okay, so the way Ryan, no, not Ryan, is this one. What's your name?
Avery.
Avery, okay, the way Avery presented it, then he, just like before, tried to trick us. He gave us an old and a new amount, but not the change. So don't let Avery trick you. 6 minus 4 is 2 gallons change.
You know what's right.
So our percent change is change divided by original. The change was 2. I like drawing these out this way with arrows because that makes me not mess up when I'm taking a test. See, I make lots of arrows mistakes anyway. So the original, I can say, oh, look, that's where the arrow starts. So 2 divided by 6, that's going to be 0.33 repeating. So about 33%. No, 0.66. My mental math is just off today. Right? No, it was right.
You were right.
I was right? Okay.
You were right, yeah.
I was right. Even worse when I don't know right. Okay. There we go. I shouldn't second guess myself too much. Okay.
That's when you know. Somebody gets called really good.
Okay, everyone okay now that I'm not messing myself up?
Yeah.
Yes. Okay, we've done 2 with a decrease. Let's do another one with an increase. Just so we have seen things go up and down. What's our situation? Yeah.
One day, a stock was, 95 bucks a share. And another day, there was no change for 2 days. On another day, it was 115 a share.
Oh, okay.
What was the increase?
So this kind of problem, again, I like to sort of draw it in a way that helps me not mess up and decide that one is the original and it's not, or something like that. It's clear which is the original. Okay, Michelle again was mean and didn't tell us the change.
What we have is,
Move all of these down a little bit. Sure. Okay. Oops, original, I am making the same mistake. Just saying.
$20 change.
I said 21.
Because I'm getting 0.21 on my calculator.
When I looked at the change, it says 20.
But you gotta divide it by.
Right, to get the percent change.
Change divided by, this is the dollar amount of the change. If I wanted to be thorough, I could label these all. But
I
I'm,
just think you're a multiplication.
what's what?
I just think you're a multiplication.
Oh, okay.
Because we were increasing it, so I thought that's what we were doing.
No, it's still a percent change, so we're still having. Yes, harder decrease one?
Yeah, like,
Sure.
say if it's just $20 and they drop down to $15.95, so that's like a change of 405.
Yeah.
And that'd be like divided by 20.
Mm-hmm.
I don't know, but it's would that be 2025? And it's not.
So, yeah, so $20 goes down to, what do you say, $15.95?
Yeah, so it's on 15.95. So that makes the change like 405.
Right.
And then you just do 405 divided by 20, 'cause that's here as well. But they're equal 20, 20, 25, right? So is that 20%? Or what do we do with the other part? Yeah, I just got the top of my head. I need to be able to put it in the real world thing, like something that I would really do.
Right.
So-
Right, exactly.
It's like
So
awesome.
Amanda's question is, how much do I round, basically?
Yeah, so
It's
it's
not
like
harder,
20%,
it's
right?
still
Right,
just-
exactly.
it's still just dividing with calculator, it's not harder to do. But before I was rounding and you were all letting me get away with it. Now, you're wondering, should we say 20%?
Yeah.
And officially, it's 20.25%, but does anyone care? No, well, most people are just gonna say that's a 20% change, right? So just whenever you are rounding, not rounding there, whenever you're rounding, put the rounding symbol. And if you wanted to write 20.25, that wouldn't be wrong.
So 20 or 20.25 or.
It's just that when most people say how much a dress is on sale, they're not going to bother with the decimal amount of a percent.
But you can write it either way.
You could write it either way. Your friends might look at you funny if you say, I bought a dress today that was on sale 20.25%. If you're up for that, then more power to you. Okay. Did that answer your question?
Yes.
Okay. But the fact that there's decimals here doesn't make it work. Right? Your calculator is still doing the division. You can handle it. Okay, there was a cool little thing we skipped because of Daniel's shortcut, which is the switcheroo trick. So if you're doing the multiplying, the what is 40% of 200 kind of problems we started with, then you can switch which number has the percent because you're only multiplying. And for multiplying, you can switch the order of things. 2 times 3 and 3 times 2 are the same. Dividing, you can't do this. Right? 4 divided by 8 and 8 divided by 4 are totally different. But for multiplying, you can. So if somebody asks you, what is 24% of 25? Then 0.24 times something I can't do in my head. But if I move the percent over to here and I say, what is 25% of 24? Well, 25% is just a quarter or something. So a quarter of 24 is 6. If that works for you, great. If it doesn't, don't worry about it. So in this case, what is 8% of 900? Well, I can't do 0.08 times something in my head, but I can move the percent. What is 900% of 8? 900% is just 9 times it. 9 times 8 is 7. So if that works for you, you can show off for your friends at cocktail parties. If not, don't worry about it. Multiply things like we did. Okay. So here is your fancy diagram. How is the word problem going to trick you? If the problem says, what is the number? What is 30% of 100? What is 8% of 90? Whatever. Then usually it's asking just for what it says. But sometimes it's asking for more. We'll get to that in a bit. You say, not only did your stock go up in price 5%, but we want to know the new price, not just the amount of the change. With the percent, then did they show or hide the change as a number? In all the example problems you had to do, the change was hidden, and we had to subtract first. Sometimes you don't. Okay, this part is what we're going to talk about next. So let's imagine a very simple case where you have something that's something that's worth 100, because that's a nice number to use with percentages, and it goes up by 5%. So we're asking, what is 5% of 100? This is how we started things with the multiplying. This isn't the percent change. The percent change, they were asking for the percent, whereas now they gave us the percent to start with. Are we clear with where we are, or should I taking a step back? So 100 times 0.05, so we'll get $5. And the new amount that we get to, we have to put together the 100 and the 5. So that now whatever this is, right, your stock that went up, your the toaster that got more expensive right before Christmas, whatever this is, then the new value is 105. So our first heads up is the green is in two places. We can find the dollar amount of the change, or we could find the dollar amount of the new value. And what we have to do is just whatever the problem asks us. So that's what this picture was telling you here. If it asked for the change as a number, you have to add it back to the original, or combine it with the original, or is it okay, all they said is how much did it change? We can go to the dress too. So we could say, let's make it a little bit different from Amanda's example. We have a $30 dress. It goes down in price by 18%. So what's 18% of 30? I'm going to do 0.18 times 30. So $5.40. How am I going to combine that with my 30 with my dress going down in price? Subtract it away, right? So now I'm going to have $24 or $24.60. The mental math okay? Oh. So there's two different answers. And it's not like one is right and one is wrong. It's just, what does the problem ask us? Do they want the change or do they want the new value? So just read it carefully, give them the answer they ask for. Questions about those? Yes, they will. I'm actually going to do a bunch with the 1+ trick shortcut. Okay, so that's what we've done so far. There's 4 issues for reading carefully. 2 when they say, what's the amount of the change? And 2 when they say, what was the percent of the change? After we multiply, do we combine it with the original or not? And before we divide, do we have to subtract to find what the change is? Or did they actually give us the change? Okay, the next step is the 1+ trick. So we did a lot of work in the last 2 slides. Not only did we find the 5, but as a second step, we had to add it back onto the 100. Or not only did we find the $5.40, but as a second step, we had to subtract it from the 30. So is there a way to be more efficient? If you know going into the arithmetic that they are not asking for the dollar amount of the change, they're just asking for the new value, can we somehow skip over this and not have to do 2 steps? Does everyone understand my question? we're going to look first at the getting bigger case, because for most people's brain, this just makes more sense. So can I get directly to the 105 without having to do this $5 step? That's our question. So the 1 plus trick says multiplying any number by 1 doesn't change it. Right? 50 times 1 is still 50, 100 times 1 is still 100, and so on. So let's use that. When we multiply by a percent increase, again, we're starting with getting bigger, so our brain's like that, then we'll add 1 to the percentage, and it will keep the original amount around. So if I go back to this slide and copy everything and stick it on a new slide, then what I could have done here, is taken my 100 and don't multiply it by the 0.05 that we did before, but instead make it a 1.05. If I do that, then I get the 105 right away. So the times 1 is keeping the 100 around, which I want, and the 0.05 is adding the $5, which I want. And that's quicker, because putting a 1 in front of a little decimal is just writing a 1, right? That's really easy. Let's do more of those. So a $5,000 loan lasts a year. At the end of the year, you have to pay back an extra 8%. So what's the new amount? So there will be a dollar amount of increase, but we're going to skip that. If you like doing it in 2 steps, you can. There's nothing wrong with the old way we started class with. But it's just faster to do this because writing 1 in front of a decimal is so fast. So 5,000 times 1.08, and so 5,004. Everyone with me? Nothing wrong with finding the 400 as a step. You could do 0.08 times 5,000 is 400 and add it back on. But this is just a quick way. There's a lot of real life examples. You might as well do it quickly. Okay, holler if I am going too fast. A $200 painting increases in value by 4%. And then what's the new value of the painting? So they're asking what goes here. Question? Oh, okay, you're just being fast. So 200 times 1.04, yes, is
208.
everyone happy? If you don't like it, don't do it this way. Do 0.04 times 200 is 8. 8 plus 200 is 208. You can do it in 2 steps. But this is cool too.
Is it always adding 1 something?
Is it always, if you're going up, yes.
Okay.
Because times 1 means keep the original around. Okay, this is getting repetitive, but that's okay. So 140 goes up by 12%. So what's the cost of the new model?
100 pages.
So again, read it carefully. If they're asking for the dollar amount of the change over here, then don't do this trick because you're getting the wrong answer. But as long as what they're asking for is the new amount, then we can be efficient. Okay, and whatever that is. All good? One more. Okay, someone get a star, come up and do it on the board. We've done a whole lot. Okay, Sheila's brave.
I don't know the math in my head. Can I bring my calculator?
Yep, or you can use mine. Either way.
Okay. So you go.
Write it on the board. so
On the
it's-
board right here?
and that way it'll
Here's
be
the
there.
board. Okay, so 750. Yeah. And then you're gonna times it by 1.05.
Yep.
Sorry, I have ugly hair.
Let me move on to the next topic.
Equals. Yeah.
You're missing one thing. It's a word problem, so
Oh. What is the new month there?
there we go. Straight with your answer. Okay.
It's really ugly.
Ta-da.
You
So
said
you
no.
haven't had practice drawing illustrations.
Yay.
Okay, and I should mark on my class list that she's one on board. Okay. Okay, so far so good. The next part, some people love it and some people hate it. So if this isn't for you, then don't do this part. If you like this, then here we go. So if we're going up, then we put a 1 in front of the percent, right? Because we're getting bigger. The 1 kept the original amount, the 0.05 or whatever was the change. We can do the same thing with a 1 minus trick. So if we have, something that starts at 100 and it goes down by 5%, it's still true that 0.05 times 100 is $5, and our answer is going to be 95. So if they were asking in the problem for the 95, then we could use a shortcut and skip the 5. Same game as before. Everyone okay with my setup spiel? What we have to do is, actually I'm going to move this there and all of that. Now we're going to do 1 minus the 0.05. Why is it minus? Yeah. We're going down, so you can take away a little bit. The times 1 is still just a positive 1, because that means keep the original. But since we're doing a decrease, then the decimal part has to be negative. And I should probably actually color that green, because it's the decimal part. Okay. That's a down 0.05. So what we're writing doesn't look quite as cute. It's not just the 1 in pink and the 0.05 that was there anyway. So if your brain is happy saying 1 minus 0.05, then you wouldn't actually write this part on the board. You could just write this and do it nice and efficiently. If that's not what your brain likes, If this looks a little bit too complicated, if that's something that on the pressure of a time test, you wouldn't be happy trying to do, then ignore this and just do it the way we did at the top, where we're gonna start with finding the dollar amount of the change, and then take that change and subtract it. That works too. Everyone with me? So I'm gonna do not as many of these, because for some people you will hate this. But for the people that like it, let's just do a couple. So if you're doing it with both steps, then first you're going to do 200 times 0.15 equals 30. Then you're going to do 200 minus that 30 equals 170. And that's what's going in the box there, right? Everyone okay with the left-hand side of the screen? If you want to do it one step, then you have the same picture. So instead, you're going to think to yourself, 1 minus 0.15 equals 0.85. And then you're going to do 200 times 0.85 is 170. And maybe the pink is something you'd write, or maybe the pink, oops, why did I have an 8 there? Sorry. Maybe the pink is something you'd write, or maybe the pink is something you would just do in your head. If this was your kind of thing. So everyone should understand on the left. If you like the right, go with it. If you don't. Questions on what's on the board? If I was Steve Self, I'd have everyone do a thumbs up or a thumbs down to say if they're with me or not. I don't know if I should do that. Okay, is Keyshawn ready to do the next one? Okay. You don't have to do both sides.
I just do the 2-step.
You do this a step. Okay.
2-step. I'm more than welcome to use your calculator, correct?
Yes, you can use my calculator.
So we got here.
So it's
Oh, I'm sorry. This marker is kind of. Where's your eraser?
the thing that looks like an ice cream bar, the third one.
Excuse me for my enormous writing, everyone.
It's all good.
It takes a lot of practice to write neatly on that silly things. It is, but then the people who aren't here are looking at it later on.
Jeez Louise.
Too much multiplying. Until I go without something
Correct.
Okay. This comma is scooted over in the wrong place right here, but other than that,
Oh.
it's perfect. So I
Where should it
wouldn't
be
try- You're gonna mess up the 10 step if you try and fix it, so I will just put a box around your answer. Good enough.
This is correct.
Yeah. Yeah, just put, the comma goes after 3 numbers. Okay, should I do the one step one for those people? So if you were doing it the one step one way, then first you'd think 1 minus 0.1 is 0.9. And then you would say that 22,500 times the 0.9. Right?
Either way, it's.
Yeah.
It is, because on the other one, the other one on that one.
Yeah, almost everyone likes the one step trick for going up.
Yeah.
Not everyone likes the one step
Well, yeah.
trick for going
because
down.
the wrong one, that's the wrong one.
Okay. Our last part of percentages, I think, let me double check. Yes, is simple interest. So let's talk about simple interest. Then we'll do that. Interest is a fee that the lender charges the borrower. If you have a savings account, then you are loaning money to the bank. So the bank pays you that fee. They give you interest because you are letting them have your money for a while. If you buy a government bond, then you are lending money to the government. So the government pays you the interest because you are the one who is making the loan. If you have a debt, like a bank or a credit card debt, then you are paying the interest because you are the borrower. The initial amount of the loan is called the principal. I have no idea where that word comes from. If somebody knows, great. The simple interest is not terribly common. It used to be more common. Now almost everything is compound interest because we have calculators, computers, and doing the extra math isn't hard as they do it. But before we had all those nice mechanical tools, then simple interest has easier math. So more kinds of loans for simple interest. So simple interest means that you borrow money, and at the end of the loan only do we do the math for how much interest there is. It's not every month there's interest like that. Just wait till it's done, and then there it is. So let's look at an example. A $500 loan lasts a year. It has 2% interest. So all we're asking is, what is 2% of 500? Okay. So that's going to be 10, right? My mental math, okay. No, undo. There. just make a blank page? I did. Okay. Okay. So this is exactly like what we've been doing. What is 2% of 500? Remember that picture with the two arrows? Did they want the 10 or did they want the 510? In this case, they asked for the 5. So a certain amount was loaned, the principal. There was the percentage, the fee, the interest rate, and it was 1 year. Simple interest is always designed for 1 year. So the next way to make it complicated is what if the loan was for more than 1 year? In this case, we're going to start with exactly the same thing. I'm even going, whoops, to just copy and paste it to save time. But that $10 is now per year. It was 5 years. So we're going to go 5 times 10 is $50 of total interest. And then we can say finally that we have the 500. It doesn't go away. Come on. And the 50. And they have to get smushed together. Everyone understands the 3 different steps? The interest rate is just a percent of problem. It tells you how much interest there is. And by definition, that's per year. If there's more years, then you have to make copies, multiply. And then when you're done, whoops, we just left out the 5 years, so we have to put it back. Questions about that? Okay, the question you should have, is there an easier way? And yes, there is. So, I have to make it smaller so it fits on the screen. That's a bother. Okay, if you look at what we're doing, we are taking that principal amount, the 500, we're multiplying it by the interest rate. So we multiplied it by the 0.02, and then we multiplied it by the number of years. And that got us to the end of the pink answer. So we can take these steps and put them together into a formula to help us remember what we're doing. Not that it was really that hard, but some people really like formulas. So that's what this is saying. The interest, and notice this is just the interest, it's not the new total. You still have to add back in the 500 or whatever. But the interest only is the principal amount times the rate times how many years it is. Let's go back up. What happens if the year amount is a fraction? So 6 months, this is going to be 0.5 of a year. So first, let's do it the long way, because that might help our brains. And then we'll do it with the formula, and it will all match, and we'll be happy. So we take the 2% of 500 That hasn't changed. That's still per year. Then in pink, we did that we take that $10 and we're going to multiply it by half a year. And then whatever other color I had, green. Oops. So that's our new total, I should say. Okay, everyone okay with that one? If I'm just using the formula, then interest is principal times rate times time. So it's 500 times 0.02 times 0.5. And that's going to give us the $5 that we got at the end of the pink step.
So,
That's still the interest amount, not the new total.
If it would have been like 2 months instead of 6 months, would you have just changed it for the percentage of the year that
Then,
was?
yes, instead of 0.5, I could just do 2 divided by 12. So the formula comes with a warning. Like PEMDAS, there's nothing wrong with it. It's a great thing. But if you were taught it before in a sloppy way, remember that it gives you the interest, not the new total. If it asks you for the interest, great, we're done. If it asks you for the new total, you have to add it back on to the principal. Remember that the rate is an annual interest rate. No need to do ripple up to it. If it's 5%, you plug in 0.05. Then remember that the time is always measured in years. So just like I said, if it's 2 months, you do 2 divided by 12. If it's 100 days, you do 100 divided by 365. So let's do an example like that.
What is the percentage? Not a straight percentage. It's like 2.25%.
We'll do that one next. Okay, so 3,500. The interest rate is 4.5%, so we'll ripple up that. If it's hard to do, write it out. If you can do it in your head, that's fine. And 9 months, I'm going to do 9 divided by 12. Do I need to write parentheses around the 9 divided by 12?
Should become easier to look at.
You don't need to. You can. If it helps you, that's great. If it doesn't, all we have is multiplying and dividing. So by order of operations, we're just going to go left to right anyway. So if it makes you happy, you can write them. If it doesn't, you can leave them out. Your teacher doesn't care. Your calculator doesn't care. Okay, so whatever this one is, let's see. There we go. So remember, this is the interest, and it asks us the interest. If it asked us the total, we would have to add on 3,500 again, but it didn't, so we're done. Questions on this one? It's about the hardest percent thing we'll do in Math 20. So if you can do this, okay, so Sheila wanted one with an annoyingly complicated percent. Okay, let's make up a principal. 8,000, okay. A rate. So what was your funny rate?
I don't know. 24.5%.
24.5%. So we're going to ripple off twice.
I'm sorry. Okay. It's not. Alright. That's all I do.
And let's do one with days, just because we haven't yet.
30?
I'm not going to do 30. I was thinking about it, but someone's going to say just do a month and 1 divided by 12, and I don't want to get into that argument. So let's do 140 days. So interest is the principal times the rate times, and then for the time, if it helps you to write parentheses, you can. If you don't like it, you don't have to. But 140 divided by 365 is how much of a year the days are. Everyone okay with this part? This is like the new feature of this problem. Some people like to write a fraction. They want to write it instead as 140 over 365. If that makes your brain happy, go ahead. It doesn't matter. Okay, and I have no idea what this is because we just made up numbers. Cents. Okay. One nice thing about these is we never have to worry about how much to round. It's all dollars and cents.
Alright.
Okay, I'm gonna mark who's here.
What were you saying if it was a 2 months, you divide that by?
The 2-month one was like this. It would just be 2 divided by 12. But divided by 12 is how to change months.
Oh, okay, so 12 months a year.
Okay.
Thank you.
You're welcome.
Would you write this down? Yeah. I put it right there. So I've got all the other ways.
Okay. Ta-da, we're done on time. Next class, bring me your questions on percents. I know it's the middle of the week, but try and spend some time on percent homework before Friday, so you can ask me questions. And then we'll do measurement stuff.
Thank you.
And I will give you a quiz that's not really quiz and do, that's quiz and do.
I don't remember my old.
That was really good.
That was years, okay, 1 moment, let me write the top. Yes.
When I looked online, I'm under Star Seeker.
Yes, you are that.
Awesome.
I don't.
Thank you.
You're welcome.
Yeah, so I haven't been here a lot.
Right.
A lot of things happening, some things just tweaking.
It's not a very good student, but it's like I'm starting to put myself in the mindset like, hey, like if I just like leave this out any longer, you're not gonna know. So
Okay, that
it's
is
like,
probably
okay,
true.
so I've been sitting down